class. So today we're gonna learn how to solve for x in one-step equations, but we're gonna do it CSI style. So let me show you a problem and then I'm gonna explain to you how it works. Why do we have a letter? Well, this letter in math is called a variable and it is x. Okay, so then you're gonna say, well, how are we gonna tie this into an CSI, and what does CSI stand for anyways? Well, CSI stands for crime scene investigation. So here's what we're gonna do. We're gonna draw a line to separate the two parts of our equation right here. Now, the first thing that we need to do as a detective or investigator on a crime scene is we need to look for the suspect. And here is my suspect. Okay, X is the suspect. He's that unknown, she's that unknown person who's done the crime. But what is with the suspect? In this case, we have the number 8 is with the suspect. And what operation is between 8 and the suspect? It is addition. So the rule to find the suspect is that we have to do the opposite of it. So what is opposite of addition? It will be subtraction. Okay, so then what we're going to do is we're going to subtract that 8 in order to cancel this out. This is how we isolate the suspect. Now this becomes 0. The suspect is all by him or herself. Okay, and then now we just have to solve for this part and we will get a 6. So we think that the suspect is the number 6. We're not sure. As in any crime scene investigation, we have to double check. So how do we double check? We use substitution. And how do we fit this in our crime scene again? We can do this again. We will use the original crime scene. We pretend that this number right here is our DNA. Okay? We're going to substitute this X with the suspect with the number that we think that suspect may be. Okay, we're going to substitute him in here or her in here, and then we're going to solve for this. Okay, so now we're going to see if we have a DNA match. Remember, this was our suspect's DNA. So after we solve for this, we're going to see that, ooh, on this side we have 14, and on this side we also have 14. We have a DNA match. Therefore, number 6 right here is the correct criminal. Okay, because we don't want to put the wrong guy behind bars. The reason why I go into crime scene investigation to solve for one-step problems is because I can give you steps to solve one-step problems, but in my mind, I don't deal too well with steps that involve just numbers and letters. I like the story. So you can actually use this for all of your one-step equations or two-step equations. Imagine the unknown. Imagine X. It may be an A, B, N, C, whatever letter it is. It's an unknown. Imagine it being a suspect in a crime scene. And look for what's the interference, what's beside what's with the suspect, who's with the suspect. Try to get rid of that person. Try to get rid of that number by doing the opposite. And by doing that, what you essentially are doing is isolating the suspect to be all by himself or herself. And all you have to do is just to solve for the other side now, and you get that number. Once you get here though, you need to make sure, because we don't know if we're going to be putting the right number or the right guy or gal behind bars. So we have to check. How do we check? We use substitution. Again, we use this exact equation as it was given to us, and this becomes our, and this is the DNA that we need to match. So what we do next is we substitute that suspect, that X, that unknown, with what we think it may be, which is the answer from here. Now, after you solve for that, if you have a match, which in this case we do have a match, that tells us that this guy is the right guy, that we can shut him behind bars. And how cool is it? How fun is it just to pretend that every single problem is a real life crime scene investigation that you can actually solve for.